Good morning, friends. And in today's lesson, we'll be looking at matter and we'll also look at the various states in which matter is. So, first, we'll be defining matter. So, simply put, matter is anything that has mass and that also has volume. Most textbook definition will tell you that it's anything that has mass and occupy space. Of course, that is true because the space occupied by objects or substances is what we refer to as volume. So if that is volume, we can equally say that matter is anything with mass and volume. So that's simply the definition you can give to matter. Now, quickly, let's look at the various states of matter. So matter has three main states. So the first state, we have the solid state, we have the liquid state, then finally we have the gas or the gaseous state. And I believe you are aware you can give examples of each of these states. But of course, for the sake of this video, I will quickly mention one example of each of the states. And for solid, we can have, for example, a stone. For liquid, we can have water, very popular liquid substance. Then for gases, we can have water vapor or you can have vapor. So these are examples of um, states of matter. Quickly, we're going to look at the various states of matter separately. And for each state, we're going to look at the properties that define them. We're going to start with solid states. And as you can see on the screen, you can find the lattice structure of solid matter. Simply put, lattice structure is how particles are arranged in the solid state matter. As you can see, the particles are closely packed together, and that's one property that defines solids. So in solids, particles are closely packed. That's the first property. Now let's look at another property of solids. When, for example, I give you a stone and we put the stone down for 100 years or even more, you'd realize that the shape of that stone will never change. Yes, shapes of solids do not change. So solids are said to have fixed shapes. So they have fixed shapes. Let's look at another property. What about volume? What do you think about the volume of solids? Do they change or do they not change? Of course, when you manage to measure the volume of a solid and you put it down and you wait about 100 or plus years and you come back and you measure the volume of that same solid, that volume would be the same. It will not change. So again, we can say that solids have fixed volumes as well. Okay, so let's look at the lattice structure of the solid matter again. We said, the first property indicated that the particles are closely packed. The question is, why are those particles closely packed? Simple answer is that they are packed because there is a stronger force of attraction that holds them together. So that can be considered as a property of solid matter. So there is a stronger force of attraction in the particles. So a stronger force of attraction between the particles of solid. Okay, so that's why those particles are closely packed together. Let's look at the next property of solids. So try and pick and compress a stone. I mean, try and squeeze it and see if you can do that. You realize that it will be very difficult for you to compress a stone. Stones or solids are difficult to compress, so that can be considered a property. So solids are incompressible or difficult to compress them, so difficult to compress. Okay, so these are some of the properties of matter in the solid state. Let's quickly move on to liquid matter and look at some of the properties that liquid matter have. And here again, I've drawn the lattice structure of matter in the liquid state. And I mean, you can see from the structure that the particles are a little loosely packed compared to that of the solid state matter. So you can say that one, particles are loosely packed. They are loosely packed. Okay. Then two, let's look at the volume of liquids. First, no, let's look at the shape of liquid. Now, when you pour, let's say, water in a round container, you realize that water will take up the shape of that round container. Try again pouring the same water in a square container, and you realize that that water will take up the shape of the square container. Maybe try pouring that water in another shape of a container, you realize that it will take up that shape of the container. So as you can see, the shape of the water or liquid keeps on changing based on the containers that hold it. So it doesn't have a fixed shape. So liquids do not have fixed shape. So they don't have fixed shape. Okay, now what about the volume of liquids? Let's use a measuring cylinder or measuring anything that we use to measure the volume of liquid to measure the volume of water. Now, after measuring that volume of water, just you can leave it there for some time and come back again and re-measure the volume of the water, and you realize that that volume will not change. So we can say that uh, liquids have fixed volumes. They have fixed volumes. Okay, let's look at the next property. And again, we're going to look at the lattice structure of the liquid. You see, the particles are loosely packed. So now, when we're looking at the solids, the particles were closely packed because there was a stronger force of attraction between them. Now, if the particles are loosely packed, what it means is that the force of attraction between these particles are a little weaker compared to that of solids. So when you compare the two, force of attraction is weak, force of attraction is weak. Between the particles of liquids. So that's the fourth character. The fifth character, we can look at compressibility. The question is, can you compress water? And again, It's very difficult compressing water. It's one of the states that it's just like solids. You cannot compress it. So it's incompressible. Water is incompressible. Okay, so that's those are the five properties of water or liquid. Now let's look at the final state of matter, which is gases. And here too, we're going to look at the various properties of gases. So again, we have on the screen the lattice structure, which shows the arrangement of particles in gas substances. And here you realize that the particles are not arranged in the orderly manner. And in addition to that, the particles move in any direction. So particles are randomly packed. So particles are randomly. Okay, so particles are randomly packed in gas particles. Then again, let's look at the shape. When you pour a gas into a solid, a round container, it will take up the shape of that round container. When you do the same for a square container, it will take up the shape of the square container. Irrespective of the shape, it will take up the shape of that container. So it means that gases do not have fixed, so they do not have don't have fixed shapes. All right. What about volumes? Of course, volume of gases is also not fixed. I mean, when you measure the volume of gas today and you try measuring the volume of the same gas using maybe another device, the volume will change. So volumes of gases are not fixed. So don't have fixed volumes. Okay, let's look at the lattice structure again of gases. And here you can see that the particles are widely apart, randomly placed. So it means that the force of attraction between these particles is even much weaker. So it has a very, very weak force of attraction between particles. So very, very weak force of attraction, right? Then finally, we'll be looking at compressibility. And again, gas can be compressed easily. So very compressible. So gas particles are highly compressible, sorry. So very compressible. Okay, so I guess that will be the end of today's class. We looked at the various properties of the states of matter, and um, first we looked at the states of matter, liquid, solid, and gases. We defined what matter was. We said it's anything that has mass and volume. And for each of the properties, solid, we said closely packed. Particles have fixed shape. They also have fixed volumes. They have stronger force of attraction between particles. Then it's difficult to compress solids. Then again, for liquids, we said particles are loosely packed. They don't have fixed shape. And the liquid has fixed volume. Then again, we said forces of attraction is very weak compared to that of solids. Okay, then again, we said it's also incompressible. Then finally, we looked at gases. We said that particles are widely spaced and randomly packed. And of course, the particles have fixed. They don't have fixed shape. They also don't have fixed volumes, and they have a very weak force of attraction between them. Okay, then finally we said that gases are highly compressible. So that brings us to the end of today's class. We meet again in the next lesson. And for those of you who have not subscribed to the channel, please do so. You need to encourage me to do more of these videos so we can help our friends who are struggling in mathematics and science. So please subscribe the channel if you have not done so, and give me a thumbs up. Okay, like the page and all of that. Thank you very much. I'll meet you again in the next lesson. Goodbye.